This is Computing Up, conversations about computation writ large, with Michael Littman and Dave Ackley. This episode was recorded October 22nd, 2020.
Hi, everybody. It's good to be back. It's going to be a fun conversation today, I think. It's already started off awesome, as you can tell. I'm going to be talking with Dave, as always, but also Jeff Bigham. Hey, Jeff.
Hey, Michael. How's it going?
Yeah, very good. Thanks a lot for joining us. So let's see. So just to give a little bit of context, why don't you say a little bit about what your role is now, and then I want to give a little bit of background on how we first connected.
Awesome. Yeah, sure. I'm a professor at the Carnegie-Mellon University in the HCI Institute, and where I work on HCI, kind of broadly technical approaches to building interactive systems that, benefit people, that we think can solve real problems.
Awesome. So Dave and I met when I just got out of undergrad, and we worked together in the Cognitive Science Research Group. And we were in a group that was a pretty HCI-focused group. It was very much about building tools for, that were going to make it easier for people to use computers. Our boss, Tom Landauer, wrote a book called The Trouble with Computers, because he really wanted to kind of get at the issue of the way we were building software and how we should do it better for interacting with people. But then, that all ended at some point. I became a professor. Dave became a professor. And then at some point, I was teaching an AI class at Princeton, where I wasn't a professor. And you took my my intro class. So I knew you before you were a professor. I knew Dave before he was a professor. Dave knew me before I was a professor. But then we all went through at least a computer science professor phase.
Yeah.
And we wrote a paper together, in fact, yeah?
Yeah, we did.
Was that your first paper?
That was my first paper.
And my first paper was with Dave. So there really is, there's a lot of, we're starting over kind of thing here.
What was your first paper called, Jeff?
Oh, wow, you're going to put me on the spot to know the title of it. What were we doing?
You can fake the title.
It was something about multiple ensemble approaches to solving synonym questions. There was an exam, like on the TOEFL exam, I believe that's what it was.
Oh, well, I can understand why you wouldn't have trouble remembering a title like that. Like that. Yeah, and so Michael was talking about Belcore. I don't think he actually mentioned that in the Tom Landauer and how we all met around in the first generation. Although one can always listen to the first episode of Computing Up to learn
right,
more about Belcore and how Michael and I met there. Well, so that's pretty, I guess that means I am unbelievably old is what we can derive from that.
I mean, at the time, when I started at Belcore, you were a lot older than me, but you are not a lot older than me now.
Yes.
Like we are converging in the limit to
Right,
being basically just old enough.
Well, I plan on living forever, so the ratio will go to 0. It will go to 1 soon
Welcome to
enough.
asymptopia.
That's right.
Now, so one of the things, yes, Jeff is well known for his work on synonyms and analogy questions, as you know. But in fact, I think he's maybe best known for the work that he has done in thinking about supporting accessibility of computers in various ways, and especially by incorporating people into the computational process. Right. And so Dave had expressed some interest in thinking about what does it feel like to be a computer? And I thought it would be really fun to talk to you about that. And when I recruited you to do the call, I said that we want to talk about computations that involve people. And you said to me, what computations don't involve people?
Ooh, yeah.
And I was enlightened. It was a very koan thing to say. So can you say a little bit about that older work that you've done, kind of set the stage for how you think about these things?
Yeah, that's a great setup. So I guess there's lots and lots of ways that we could imagine computers benefiting people with disabilities, and lots of ways that we can imagine people with disabilities having a hard time using computers as they are created today. And so what we've done for a long time in my group, and when I was a PhD student before this, we've looked for different ways that we could use largely artificial intelligence, machine learning to improve interaction with computing. And one of the big problems we had was just that it didn't work all that well for real problems, right? There's just all these really hard real world cases where machine learning just isn't good enough. And so I started looking at, well, what if it wasn't just AI that we relied on, but what if we could rely on the intelligence of people? And it just so happened what was going on right at the same time was that people were getting much more networked to get together. So it was a lot easier to kind of reach out into the world and find people that would do tasks for you. And you could actually get them to do tasks almost at interactive speeds for you. And so the first real system that I created in this space, it was an iPhone app that people who are blind could use to take a picture, they'd speak a question, and we would recruit a person in seconds to answer that question for them. And so that they could kind of experience like basically a computer vision system, like a VQA, like visual question answering system, but not solved by computer vision because it just couldn't work well enough, but solved by people. And that was a start for me. But of course, it went kind of wild after that.
And so these are the sort of the Mechanical Turk, the Amazon thing that has built this whole infrastructure to provide human mind power, kind of at the drop of a hat. That is part of what makes this sort of thing possible.
Well, and interestingly, they call it, one of their taglines is artificial intelligence. And is that what you used, Jeff? Did you actually
Yeah, well, we tried a bunch of different things. Actually, so I will say when we first released the system, it was like 2010. It was people in my group that were answering all the questions.
Excellent.
Right?
Oh, wow.
And I imagine, you can imagine what that looks like. I'm like running. I remember running on a running trail in Rochester, New York, where I was at the time, and getting questions and just stopping my run and say, oh, somebody's got a question. So I can just type in an answer. So it really was just like reaching out to, in this case, me and my lab mates. But then as we scaled it out, we released it, we put it on Mechanical Turk, and then we explored, Mechanical Turk, but also like, what about people on Facebook who just want to do something nice for each other? What does that look like? Can you post these questions to social media? And there's a whole bunch of intricacies about how you do that well and get good answers back.
Right. I mean, talking about Belcore way back in the dark ages, one of the sort of thoughts that we had going was, that sounded like a car. Way back.
Yeah, sorry about that. Right? Did you hear my kids too? My kid was in here for a second.
Heard your kids too, but kids are always appealing. Back at Belcore, one of the things that we used to think about was a mantra, a phrase. Would you pay a nickel for an immediate confidential answer to that question? Like that. And the idea that you ought to just be able to open your mouth and speak to the air and say, what is the song playing on XQP2 right now? What is the asking price of the house I just drove by? And so forth, and get an immediate confidential answer to that question. And it sounds like, with at least with the blind, take a picture, get an answer, it's a little bit of that flavor, actually starting to happen through, a people-powered infrastructure.
Yeah.
What's an example of something that somebody might ask?
Oh, it's fascinating. So we released this. We got a little over, I think, ended up being about 120,000 different questions over a couple of years. And so you might imagine there's just like a wide variety of questions. And so one of the talks I like to give is basically just a run through of kind of the types of questions. But I'll just give you some examples. So I often start with, there's this picture of like a horizon. There's like, a house and there's a sky. And, I give the example of when we first released this, the same person asked basically, what is this? Over and over again, like every minute for an hour, right?
The same picture.
Like, well, I mean, it was slightly different. It's a new picture every time, but
okay.
We were like, what is going on? Like, and we're answering the questions at this time, and it's like, there's no way we're going to be able to support this service. Whether it's us answering or if it's Mechanical Turk workers answering it, we're paying them money. There's no way we're going to be able to answer these questions if people just keep asking these questions. But anyway, after the hour, the person, stopped, these questions stopped coming in, and we just happened to be monitoring Twitter at the time, and we saw somebody tweet, I just used VizWiz to watch the sunset, right? And so the detail I didn't tell you, right, is that, the sky went from light to dark, and, there was a sunset in the middle. And that's just kind of like way out there in the outliers, right? I think a much more common are things like we would get people asking like what the labels are on like frozen foods. We got medicine bottles, right, which people are sort of worried about. We got like, questions about, my clothing. Does my clothing match, right? We had this whole like side project, which I think people are often glad to learn that I did not actually lead, about like, how do you give people effective fashion advice when people's style is different? you probably don't want to connect like a person to just a random worker on Mechanical Turk.
Right.
But
Yeah,
then,
I mean, my strategy for this has been to just keep having kids until one of them has fashion sense, and then I'm good.
did that work out?
Yeah, pretty much. The first one, not so much. The second one, we're done.
That's awesome. But I think there's a really good question in there. And so as we went from, just accessing the raw human intelligence of a Mechanical Turk worker and started thinking more about like, what would an algorithm look like that incorporated human intelligence? Shouldn't it be the case that we could somehow build the expertise into the algorithm and then use the human power for things like perception and things that feed into the algorithm? So you could imagine like somebody who doesn't know anything about fashion actually like feeding into a whole algorithmic process that does give good fashion advice to people.
Now, between 2010, when you said this was kind of getting off the ground, and now I will call it the deep learning revolution happened. And so there was kind of a big leap ahead in terms of at least the proclaimed capabilities of a lot of these systems. They're better at voice recognition. They're better at object recognition. They're better at language generation. Has that had an impact on your thinking about how to get these problems solved?
I mean, yes and no. So I will say when I first started this project, I was in Rochester and I drove down to Cornell to visit my friend Noah Snavely. And I said, like, look, I've got this really interesting system. We're collecting this super unique data. Do you think we can apply computer vision to this problem? And he was basically, this is 2010-ish. And he's like, no, right? And 5 years later, if nothing else, there is a deep confidence that has come with the, deep learning revolution. And so people have started to work on this problem. And it turns out that, around this time, every week, other people have started the VQA challenge, which was, this challenge where you're doing literally what VizWiz was doing, but first on kind of images that they kind of asked Mechanical Turk workers, like, what could you ask about this image? And then what would the answer be? And we gave them a really good actual use case for this, right? Where it's an actual image with an actual question somebody asked, and you can get answers back. And so we've now had the VizWiz challenge at the last couple of CVPRs. So, I think it is getting there. But of course, the questions are really hard, right? Like, in general, some of them are easy, some of them are hard, and we still need people in that process.
Yeah, the sunset one might have worked out nicely, though.
If you knew that you were helping someone see the sunset, it would make it a lot easier to answer the questions. Whereas if you're trying to say, it's a lot like the last picture. Go ahead.
Well, one really great example where I think it's just, having a person there is really helpful is it turns out that, if you're blind and you're not able to, see where you're aiming the camera, a lot of the photos that you end up taking aren't of the thing you're intending to ask the question about, right? And so, you could say like, what does this package say? And what you see is like a little corner of a package, maybe in the right corner. Right. And so a person can say, I think you intended to take a picture of that thing in the right corner. Maybe you would move the camera up to the right and you'd get it. Or like, the lights are off or the fingers over your lens or lots of stuff like that, right? Like where it's really, you're asking a visual question, but the answer is sometimes more related to, human common sense reasoning or something, which is much harder.
Right, or the mechanics of image acquisition.
Well, and inference, right? Just like the context in which you're asking that question doesn't quite make sense. But if only you tilted a little to the left, I think maybe we're back on track. I mean, yeah, it's really interesting, and people do that very naturally, or at least I guess cooperative people do that very naturally.
Right, and so that's one of the things that I wonder about with this sort of thing. That if you're saying, this is a one-off interaction, you do not have a pair of eyes, someone or a team that you're going to get someone that you build a relationship with. It's a new 10 goes every time you have a new question or whatever it is like that. That makes sense as a sort of a prototype. It makes sense because it's of the affordances that the cloud provides today. But it seems like it isn't necessarily the way that one would really maybe want to go about it from a standing start if one could organize the human interactions more. You see what I'm saying?
Yeah, well, I'll say, this is 10 years ago. One of the things that's definitely changed, which has nothing to do with AI or HCI, is just the network capability of our mobile devices. Right. And so there are programs out there, like Era is the name of one, where they pair a person with a live video feed to an expert worker who, helps them through the entire interaction. And it was totally a limitation of this, one picture, one question, and, answering paradigm for sure.
Well, but it also means that you can sort of get clean data at that kind of experiment because, it has a sort of finite term rather than you have to say, you've got this interaction that stretches over who knows how long, and so on. So from the scientific point of view, it seems like it's handy at least to start to have something that has these little more digestible pieces. But, this feels like, 1,000 years ago, 100 years ago, it would be the grandkid who's answering the questions for the grandma, who can't see very well anymore and is guiding her around the village or whatever it is. And we're sort of pulling that out and putting it through this sort where it goes through this centralization in the cloud and then pops out again to centrally recruited answerers like that, and at some degree, I worry about that a little bit, having things structured that way, as opposed to trying to. And I don't know how to do this, to try to make a way that would encourage durable relationships at appropriate scales, rather than going from individuals to totally centralized and back out again. Does that make any sense?
I think it totally makes sense. I will say this was not a replacement for the other ways that people have to do sense making. And so people are still texting images to their friends or family. I will say that there are some questions where what was surprising to us, what we learned was that a centralized kind of, anonymous,
faceless answers
was actually seen as preferred. So one example that I didn't show you or I didn't tell you before was, we have gotten pregnancy tests through this. Where, depending on your situation, you may not want to, ask your family member, to interpret your pregnancy test for you. And this is one of the places where, as far as we know, there are not accessible pregnancy tests. There's often this little line that you have to see, or there's even the digital readouts. It's a digital visual display. So it's a fascinating question, I think, what people want to ask a kind of an anonymous crowd versus a person they know.
And then I would I would hope to believe the crowd really was anonymous. If that becomes a selling point, as opposed to asking my nephew who's going to blab to everybody, whatever it happens to be.
Yeah, I think we have this, this is completely sort of different topic, but we have this paper on how Mechanical Turk isn't actually anonymous in a whole bunch of different ways. You're getting at it from the perspective of, I could submit my photo there and maybe I reveal who I am, or maybe somebody who knows that I use this service could go on Mechanical Turk and look for my images. Fortunately, I think we were early enough days and small enough scale that we don't think that happened. On the flip side, people often think that Mechanical Turk workers themselves are anonymous, and one of the things we found is that Amazon, I think to this day, and certainly a few years ago, use the same ID for workers as they do for your general Amazon account, and we were able to go in and half the Mechanical Turk workers had things like wish lists set up. They had I don't know why you have a public profile on Amazon, but people do, and it just breaks that whole anonymity. Fortunately, Mechanical Turk is really, though, the academics' playground, right? And for better or worse, and there's a lot of worse, a lot of the crowd work that happens is in these, firms that we don't actually have too much insight into. So, different problems, but it's definitely a good point.
Oh, that's fascinating.
So one of the things we try to do on this podcast is kind of talk about some academic stuff, but, a little cut loose from the standard bounds of academia. And I find that you actually are already really good at that. Your presence on Twitter is quite your thing is called Rogue Bigham, and I think that kind of sets the tone a little bit. You're definitely untethered. So what's your experience been sharing things on Twitter? Has that been a positive thing? Do you find it to be valuable? Is it more of a just blowing off steam? What do you get out of it?
I think all of the above. I will say when I started as a faculty member, the only HCI faculty member at the University of Rochester, I love the computer science department at the University of Rochester, but I will say having Twitter there as sort of a virtual peer network to build from, to learn more about what's happening in HCI. That's where I really got started. And I think it was incredibly important for me to kind of build my professional career. Clearly, over the last few years, it maybe has kind of gone beyond
Unhinged.
the professional bounds, the unhinged. Thank you, Michael.
Well, it's now national policy is made there, which that doesn't make any sense to me at all.
That's totally true. And one thing I have tried to do on Twitter and is connect with folks in AI, because I think that not only do I just find it very interesting. I mean, my first research paper was an AI research paper, but also I like to see myself as one of the kind of relentless supporters of humans in AI. And I think humans, back to the original start of this discussion, I think humans, not just computation, broadly, but in particular, humans are so core to every stage along the development of an AI or machine learning project or product that I think we need to pay attention to that.
I mean,
so beyond your research on basically systems that are supporting people using AI-ish kinds of things, even if they're people doing the AI-ish kinds of things, what other ways are you helping to bring to sort of humanize AI?
Yeah, well, so a bunch of different things. I mean, one thing that I did a couple of years ago is I started a new class at Carnegie-Mellon in human AI interaction. And it turns out that there's a lot that we know and a lot we don't know about how you build effective, intelligent, interactive systems. And while a lot of the work that I did was kind of focused at bringing people into this, a lot of it's also about machine learning, right? Like, where can the machine learning work well enough that we, that it can be reliable in use cases that people depend on. And so accessibility is a really important one, because we can't just get away with saying, oh, it sometimes works. It's got to really work. One example, this goes back a few years too, where we developed a system for what's called real-time captioning. So this is, you speak and you convert to text. And obviously automatic speech recognition has come a long way. A few years ago it was worse. And even today, if you have that as an accommodation as a deaf or hard of hearing person, you will want the human captionist there who can do a lot of these kind of edge cases and stuff like that. So one system we built, I think, is a good example of like, how can you pair like the strengths of people and the strengths of machine learning is we had, one person can't actually type fast enough to keep up with somebody who's speaking like a lecturer would speak, or like really fast, like me right now. And so what we did is we had multiple people type. So we broke up the audio into different segments. It turns out one of the things we did that was kind of clever from the interaction side is we gave them the whole audio sequence, but we kind of slowed down the part that we wanted them to speak. And then we sped up the rest so they get back in real time, and then we'd slow down and speed up. And so they type all those things, but of course the edges weren't perfect. And so we then did an alignment process, which was the machine that took those pieces and stitched them back together. And the machine's great at that, way faster than people could do. But the people are better at kind of interpreting what someone's saying and putting it down into text. And so that's just a good example of where we combine what people can do and what the algorithms can do.
Interesting.
Nice.
One of the things I think about is, I guess this is associated with Lawrence Lessig or something, the East Coast code versus West Coast code, and that West Coast code was supposed to be programming and software or something like that. That seems completely unfair and ridiculous to me as a not West Coast person. And East Coast code was law. And it does seem to me there is a fundamental connection that, if we're viewing computation writ large, if humans themselves are kinds of machines, not just a matter of working with machines, they already are machines of some certain sort. They happen to be wet and gooey rather than copper and sand, but, they're still machines. Then the laws of society are computational laws. They will make certain things possible, they make certain things less possible, and so on. And I mean, I have no idea what the answer to this is. I'm just going to put this out there because, that it seems to me that especially with the internet and communication, there is increasing, we're getting closer to a major transition in evolution. We're getting closer to having another level of organization wake up, get the latency down amongst societies or groups or thousands of people or millions of people. I don't know. And you look out in the world and you see, I don't know, China with a sort of semi-centrally planned thing that nobody really knows how responsive the center is, versus things that try to be democracies and are stressed in all kinds of various ways. As these are types of computations involving people. That people are part of it, and that is just happening. And the question that keeps coming to my mind is, can we understand that using computational or algorithmic or statistical or processes or network ideas, something? And maybe ultimately have some preferences, maybe actually have some motivation for different preferences about how we want to organize these things. So I don't know.
So like a society is a computation, or a government, not just a government, but the government and the people being governed, like that unit.
That whole thing is a computation.
In a sense, a computational system.
That's right. And it works or doesn't work, however it is. It has whatever affordances and illities it does have and doesn't have.
Right. The same way that like a cloud, a computation that's organized on the cloud is going to be good for certain things, but it's going to have trouble with other things.
Exactly.
What are the strengths and weaknesses of different forms of human organizations, human computational organizations?
Right.
I mean, I will say, like, organizational theory and folks who study this, I mean, they have sort of been putting forth like at least this general idea for a long time, and I think that it's maybe not so different than we think. I think we see it, and maybe it happens faster, and there's certainly consequences to that. But like one of the things that I would argue, right, and one of the reasons I said, what computation isn't human is that, computation never happens in a vacuum, and there's always an organization or always a set of people behind it, right? And so even when you talk about, an algorithm that's being used to make decisions in some setting that's a very high impact setting, there are people there, people who built that algorithm, who trained that algorithm, who chose to use it, who interpret its decisions, who enforce its consequences. And so, and many more. And they're all connected in all kinds of fascinating ways. And there's probably not just one algorithm, right? There's all kinds of different things that have fed into like that whole messy being, right? And I do think it's really hard to get our heads around that. I do think that's why, for me, a lot of these problems that could benefit from intelligence are often sort of like this interesting mix of understanding, like, what can AI ML do that's useful? And then also, like, can we understand, like, the people? Can we figure out how to usefully, incrementally design solutions that would benefit, this whole set of folks that would be affected? And I think that's a very human problem as well.
Dave is thinking that through.
Well, yeah, I'm trying to get my head around it. I mean, so it seems like there's parts of the process that involve humans, but it doesn't feel essential in some way. Maybe it is, like the enforcement sort of thing. Why couldn't RoboCop do the enforcement, or the
who made RoboCop though?
The real robot RoboCop, the one that has no human inside it.
Who oils the RoboCop's like gears when they run out?
Right. No, I agree that one can take it out that way, but it seems like it becomes less and less essentially human tasks. Working an oil can doesn't seem to require the great subtlety, or I don't know, maybe it does. Maybe just, the hand-eye, whatever it is, something like that. I mean, it seems like there's this vision that humans are supposed to be, the smart ones that in charge. And if that's being turned over to a trained network, the, parole versus no parole decision or whatever it is, the fact that humans are still involved in putting the guy in handcuffs or kicking him out the prison door, is that super key or not? I'm not sure.
Well, I mean, I think you'll find that many of these organizational systems, right, there's power structures, yes. There's oppression. And, there's an interesting question. I know sci-fi has certainly explored many, many stories in which the robots sort of have become the powerful, have become the oppressors.
Right.
I think probably a much more likely near-term scenario is that, people are still kind of the main presence in those power structures, but they're using technologies in various ways, right, to kind of build that power, enforce that power, things that people have done, but maybe to a scale and in a way that we have a hard time really grappling with right now, and that is sort of scary.
You mean because everything's bigger, faster, more connected, whatever, you can put out 1 million fake tweets in 10 seconds or something, that sort of stuff.
Yeah, I mean, I think it's really hard to even reason about like what all this will mean. Right. I think it's important that we see these problems, and I think it's important that we see these not as, machine learning versus humans, but as kind of this big combined system of many, many different types of actors.
Right.
Like, Michael mentioned my Twitter account. Like, one of my favorite, like, kind of, memes that I try to propagate is, there are always these Twitter accounts that will say, like, machine learning did X. And I always retweet it with a quote that says something like, well, people did X, right? People chose what problem to pursue. They built the algorithm. They tested it. They wrote the article about it. They told you that it means more than it probably does. I mean, there's all these great things that that people are doing, and yet we are so willing to sacrifice our agency to an algorithm.
Yeah. Well, we're bored with people. People don't seem to be new.
It's sort of a dog bites man, man bites dog,
right,
sort of thing.
Exactly.
Right? Like, it's more fun to talk about the computer doing it. But I think Jeff's point is really important, because it's a fun way to talk about it, but then it sort of gets into people's minds that way, and then they make weird decisions thinking that that's reality. So I don't know. Not to make too much of a fuss about this, but I don't know. Maybe 5 years ago, there was a lot of debate in the popular press on AI sort of rising up and dethroning humanity, right? Eliminating us and causing us to become extinct. And I think what we're seeing now is some really bad stuff happening with AI,
right.
But it's not what we thought it was. It's not what we feared it would be. It's not that the AI has this kind of goal and it's this separate entity and it's kind of pulling us away. It's actually systems that involve computers and people are exploiting people in a way that's bad for people.
Right.
And so you can't draw the line and say, well, this is AI's fault, and you can't quite say, well, it's that person's fault. The system as a whole has sort of organized around this sort of exploitative, extractive interaction that we should be aware of, and we should be being more intentional, I think, about thinking about building these systems, or at least intervening in these systems.
Yeah, I 100% agree. I mean, I think to your point, sometimes when we make it too simplistic, like the ML did whatever, the AI did whatever, then it sort of makes it harder to have that conversation about, what's the whole system in which this operates in, and what are the guardrails that should be there? How could we imagine kind of setting up incentives or structures so that, things don't go off the rails? And it's hard because things move fast and we don't even know necessarily what we're shooting for, right? Like, I think it's really hard to design, ML systems that meet our values, when I think it's really hard to articulate our values sometimes that in a way that everyone agrees on. But it's something we should certainly be striving for.
Well, everybody is never going to agree on it, because there's a log percentage of people who are doing extremely well with the way it is now, even if people are, everybody else, 1 minus log are doing terribly. And so, I mean, I think there is hope to come up with general principles that could inform system design, kind of independent of what exactly type of ML you want to use, or whether it's a mechanical Turk or not, or so on and so forth. And this goes back to 2 or 3 conversations ago with Jenna Burrell, that it's the small is beautiful take on systems, not just economics, but systems generally. And this seems to be it only took me 60 years to sort of notice this, that as a computer scientist, I had been all in favor of, centralize everything, let God sort it out. Give everybody an IP address, let everybody talk to everybody, and then we'll figure out what to do with it. But what in fact happens is, that flows through concentrators and concentrators and concentrators, and it becomes a zillion IP addresses all talking to Facebook and then going back out again. And once you become one of those centers, a Google, a Facebook, an Amazon, whatever it is, it's in your interest to destroy as much intermediate intermediate structure as possible between the end users, the people, and you. So things like, user groups, unions, whatever it is that would have been other levels of structure between the individual and whatever counts as the center. That's what we need to be in favor of. That's what we need to be looking for ways to do, and coming up with I don't know what it might be, the guild of describing pictures to the blind, that, could have some pride and agency in the process that they're doing like that, rather than just being 2 cents on a Mechanical Turk and then move on. And, how to encourage that, how to research it, I don't know. Maybe, Jeff, like you said, the organization people have been thinking about this stuff forever.
Well, no, I don't necessarily think that anybody has the exact answer. I do think that, empowering folks who care and focus on people in the design of such systems is really important, right? And that matters, I think, across the whole development cycle of anything involving computation, ML or not, but especially within ML, right? Deciding on a problem, like, why are we even working on this problem?
Yeah.
Like, what data should we collect? What problems are we going to... And once we get, like, somewhere far, should we actually do this? Right? Like, there's so many different questions that are human questions that don't get asked or get asked way too late. And, if we recognize collectively that what we should be doing is, putting that at the forefront, people are at the forefront, people who work with people understand how these might affect people are at the forefront. I think it's powerful. And, if you're trying to create things that people will really benefit from and use, that also helps with that, right? It's people are at the beginning and the end. And so we should put them
right.
We should recognize that, I guess.
Right. Yeah.
So let me take a stab. So I think I'm hearing what Jeff is saying. I'm hearing what Dave is saying. I think I'm starting to understand Dave's question a little better. Maybe I could take a stab at re-asking it. So I want to use the word healthy. I want to say, like, how do we organize people into groups that is maximally healthy for people? Like, what is it? What works for us? And it could very well be that the example of, what we're going to do is we're going to completely atomize everything, where if I have a concern, I'm going to put it out into the crossbar and it's going to connect me with some other random person that I'm not otherwise connected with, shrink that distance to 0. I'm going to get one disembodied answer and then I'm going to move on. And there's no relationship. There's no structure to that. It's really just, it's a bipartite graph, right? There's like the people who have needs and the people who have the ability to satisfy those needs, and they can all be connected to each other. That's better than some things, but maybe not optimal. What's the human friendliest way of organizing groups of people?
Yeah, I think you're right. And this is one of the big changes that has happened. I've seen happen in the crowdsourcing human computation field over the past 10 years. So when I started working in this field, it was very much like we have these micro tasks. That was a big word that everybody used, micro tasks, and they were all decontextualized, right?
Right.
If you haven't read like Snow Crash, right, there's this great like 3-page example of what a micro task might be in the future, where the protagonist's mom is like working for the government on some task, but she only gets to see ever like this tiny little piece that is so divorced from any context that she has no idea if she's,
Right. It turns people into computational units that we know how to reason about using the standard tools of computer science. And I think Dave wants to rebel against that a bit and say, well, we want computer science to be thought of as a systems organization discipline as well, not just this sort of how do we break things into these tiny little
And so this is been the big change, right? So now the big focus in these fields is recognizing you actually get massive benefits from recognizing that people are people. Not surprising. I don't know why we ever forgot that. But for instance, like if you can train a person or a set of people to do a particular kind of task, you actually get better results because they're actually sort of building an expertise.
Right.
One of the NSF grants that we have in my lab right now it's like a future of work grant where we're actually trying to build in opportunities for learning into some of the standard like machine learning labeling tasks that people do. So like maybe as you're labeling these images for self-driving cars or other things, you're actually building some competencies in what now we're looking at sort of core computer skills. Like, can you teach people to use spreadsheets while they're doing Mechanical Turk work? Because it turns out that learning to use spreadsheets is one of the kind of core computing tasks that they'll ask you about at a lot of different kinds of office jobs, or even not office jobs. Like if you want to be a manager at Walgreens, it turns out like they'll ask you, can you use spreadsheets, because you got to fill out the time sheets and payroll and all this stuff that's in spreadsheets. And so we're trying to figure out, are there ladders that can build from this work that, unfortunately the machine learning algorithms are sort of need this very narrowly defined work. And to train them, you need some person to have gone in and done the narrowly defined work. Yeah. And so can we figure out ways that don't just like keep the worker there, but so that you can actually build up to higher level skills? So I 100% agree that it's very dystopian to think about like people as computational units, and we have to some degree started to move past that.
How do you evaluate that kind of thing? I mean, I feel like this is one of the challenges of science, is that you have to chop things off in order to get a population that you can have multiple instances of that you can do statistics on. And so if you're saying how many people get jobs at Walmart, you're going to have a data problem.
Yeah, I mean, the classic thing is maybe you look at a nearer term metric, right? Like, what kind of learning gains can you show on a particular kind of computing task, for instance, and then you can correlate that. So yeah, so that's the sort of thing you would look at. But I mean, that's also something that, in general, HCI is at least reasonably competent at coming up with human metrics for things.
Uh-huh. I mean, so a long time ago, maybe a decade ago, I went to a workshop that Pietro Michelucci was running on human computation, because, he's like a super energy ball of human computation, like that. And he thought I might be a good addition. And in the end, I don't think I really was. I mean, I tried to give good meeting while I was there, but, there was a fundamental disconnect that eventually he and I sorted out by email, that, he was thinking about the sort of human augmentation idea, that do the good things that computers are good at and have the humans do the things that humans are good at, and that there was a qualitative gap there, whereas I was in this much more aggressive position that we're all machines, and the failures of machines to not be human-like is just a failure of computer science and engineering. It's not a failure of the nature of manufactured computers. So I would think, another possibility is that they should all just do what they all want to be, living systems interacting in whatever useful ways it is. And it's not that, my God, that humans are going to fill in the gaps of what machines are bad at. That is not a destiny that we want to be heading for, like that. And, again, I don't know how to make this march. I don't know how to turn it into an NSF proposal. But it's something that sort of just looms larger and larger in my mind the more I think about the penetration of manufactured computational systems into our world.
Yeah, and I think it's a really good point. I mean, I think a lot of the formerly human computation folks maybe describe themselves more as these human AI collaboration or human AI interaction people, because I mean, fundamentally, I don't think it's so different, right? So what we have all sort of been thinking about for, I don't know where you want to start, but at least as back as far as, I don't know, Doug Engelbart or someone, right? Like we're talking about like, how can we more effectively work with computers to do things like amplify our abilities, or, make ourselves more efficient, or, have more impact in the world with our limited time and our limited abilities. And so I think this is all the same thing. The thing that kind of got changed there is this networking capability, so that it's not just me and my computer. It's me, my computer, a million other computers, and a whole bunch of other people that I can now kind of contact with minimal latency. And so I think we're all trying to figure out, well, what do we do with that, right? And how do we make that actually make me more effective, make me be able to accomplish more? And I think we're still figuring it out, right? Quite honestly. But we're seeing a lot of really cool stuff. I mean, that don't try to solve the entire problem with people or with AI, but find kind of clever ways to help people work together with machines or with other people.
Right. I mean, I think the sort of like, the Hong Kong protesters and all of these, the activists, the BLM folks, who are coordinating on, using social networks and other kinds of mesh networks and all, it's evolving before our eyes, especially as it gets opposed. And that, they are building machines on the fly. They're building them and deploying them and rebuilding them daily, like that. And that, on the one hand, feels sort of like properly organic. That is really the fact that we're allowing this connectivity, this incredibly general connectivity with very few turnpikes that you have to get through to get from A to B, means that sort of thing can happen. And, all of the counters and the spies and the people listening and all the meta games are all happening as well. But it does seem, for all its, limitations and concentration and so forth, to be an extremely powerful machine that we really don't know what kind of computations we could just put together, boom, just by someone tweeting something that hits everybody, and then the world has changed.
Well, one really fascinating thing, this is an observation made by Zainab Turfaki, I think, in Tears and Tear Gas, I think is the book, right. Where, the Arab Spring was going to be this amazing, like, revolution. And then, of course, two things I think came out of that book I think were really, really interesting. One is, of course, it didn't take too long for the oppressors to kind of, be able to adapt. Use those same channels. But I think the other one, which maybe gets to your point that you were making before, is that, some of these movements that are able to come together so fast, they don't necessarily have the benefit of the long, hard work to build organizations that would have previously been required to build a big movement. And so they might have a lot of energy, but then it's not completely clear who's in charge or like what the movement wants as a whole. And there's a lot of interesting characteristics there that are different than they were before, and arguably could benefit from, I don't know if it's a computation or something else, but reintroducing some of those organizational aspects that are not there, because everyone is able to be gathered so quickly. But then they're like, okay, we did something. Now what?
Right. Yeah, and I can tell the story either way. That the fact that it has no leaders is a strength, and the fact that it bends like the reed of grass rather than the mighty oak getting blown over by the thing. I guess that was Mao. So I remember talking to grad students about Occupy Wall Street, and they were all really bummed out about it. They thought it was all, it came to nothing. And I said, no, you're crazy. It changed the world in its own little way. The fact that it happened, even if, whatever XYZ goals you refuse to illuminate, to state or did state, whatever, it doesn't matter. The fact of it being there, I think, has totally underpinned a lot of the kind of things that have happened since then, and that is the, it's not a ... You can't write causality to it, but that's not the way things really work in the world. You put things out in the world, and they shift the context, they shift the zeitgeist, they shift the conversation, and then the next conversation is different. And, again, with the social media making the conversations go so rapidly, like that, we shall see. I don't know. Well, I don't know. I mean, I want to try to end on something positive, even though I'm worried about.
I have a positive.
Oh, great.
It doesn't have to be the ending, but one of the things that I've been sort of promoting, which I think is totally true, is that Michael very, very early in this podcast mentioned that there's been a lot of recent developments in machine learning, and things are becoming much more powerful. And so one idea that I think is really powerful is the idea that we are in this kind of AI autumn, where we've set ourselves up for a really incredible harvest of human-centered work that goes into applying all of those great advances in machine learning toward real human problems, right? And so maybe some of them are these really complex organizational, structural system problems. But I think just with the tools we have now available, if you go take the time to understand what problems people have, there's just an incredible opportunity to apply machine learning to real problems. And so that's a positive for me. I get really excited about that because I think there's just endless things that we can do right now that would have been a lot harder 5 or 10 years ago.
Oh, that's great. Yeah, and so I mean, like the Raspberry Pis or whatever comes after it that are going to be deep learning boxes, and they're going to cost $25, and you'll be able to deploy that sort of thing just sort of anywhere. I mean, 1 more generation, 2 more generations, I don't know. I mean, it feels to me partly in the wheel of hardware karma that we don't need to centralize this stuff. The fact that we need to centralize it now is half a compute thing, but it's more a data thing. And if we could instead have incredibly rich data just about me for my deep learning Raspberry Pi that lives with me and will sacrifice itself and erase its flash drive before anybody else can touch it except me, then we can start solving problems for people in this kind of retail way, and maybe get the best of both worlds.
I want to do that.
Yeah, let's do that.
All right. Well, I got to get to work. So it was really great chatting with you guys, and got things to think about.
Well, Jeff, it was really good to meet you and to have some conversation, because I think this really is important stuff, and keeping people in the loop is, well, it's easy to say, but it's harder to do, and it's harder to really own. And that seems like an important part of what you're doing.
Yeah, I really enjoyed the conversation. Thanks, guys.
This was Computing Up. Thanks for listening.